Okay, I'm going to talk about continuous delivery for sort of packaged and on-premise software. And I'm going to try and make that super interesting. It's called In Praise of Slow. I'm going to talk quite quickly because I've got loads of material, and as people will tell you, I talk quite quickly anyway. If I do go too fast, someone shout at me. Okay, so I'm Gareth Rushgrove. I'm Gareth R, basically pretty much everywhere on the internet. I work for the software vendor Puppet. So I live and work out of Cambridge. We're scattered all over the US, UK, sort of engineering office in Belfast as well. We do basically infrastructure management software, which people are probably reasonably familiar with. I'm not talking about like the use of this tool, but you should totally use this tool. So what am I going to talk about? I'm going to cover a little bit of sort of, I guess, teaching people to suck eggs, really. Sort of like, what do we mean when we say continuous? Because I want to put it in context of the things I'm going to talk about next. I'm going to talk about why the world of enterprise software vendors is super interesting and why it's different, I think, to what certainly some people in the room will do. Who else in the room would they say work for a sort of software vendor? Yeah, a couple of hands, but not many. That's good. See, I'm super interested in what both camps think. I say at the end. And I want to talk about as well, like not just like why it's different. Differences are interesting, but I want to talk about practices and patterns that I guess have emerged from the continuous sort of delivery, continuous integration sort of tribe from this group of people, but are still relevant in that space. I think a lot of the sort of practices we talk about implementations that are quite specific. I'm trying to drag them out of being specific, then put them back into another specific domain and see what happens. Most of the examples are infrastructure tools, because I'm an infrastructure geek. I think they're generally applicable. I've talked to other people in sort of different stratas of sort of selling software and having sort of on-premise enterprise type sales channels. So hopefully it's relevant to anyone outside that area, even just as an exercise for the listener. Okay. So what does good look like? What do we mean when we say continuous delivery? I think most people, or a lot of people, are certainly going to reach for the book. Obviously, Claire's not here, Jez isn't here, but like, hopefully most people have read this if you haven't read this book. I'm not going to read the quotes, but ultimately, we're talking about the ability to make changes of all sorts of types and get them into the hands of users safely and quickly in a sustainable way. I think a lot of people focus on quickly, continuous, quickly, and a sort of mental narrative sort of builds, a mental model builds, and you start going, Amazon and Etsy or Netflix or Flickr, depending on how old you are. Like you hit one of these things or many of these things. And quotes sort of come into your head a little bit. Make sure I don't drop off the back of the stage. 10 deploys a day at Flickr. I mean, like this was the sort of seminal sort of Allspore and Hammond Velocity Conference talk. Amazon deploy every 11.5 seconds, again, from Velocity. That's in 2011. I don't know what that number is now, but it's probably scarier. But everyone quotes this one because like this is one of the times they've said it in public. Public messages are good. And a quick show of hands. How fast are people deploying today? So who's deploying every week? Keep your hands up. Who's deploying every day? Who's deploying many times a day? So there's a load of hands. There's people deploying more slowly, but there's a lot of hands, and that's a lot more hands than there would have been 5 years ago. 7 or 8, 10 years ago, whatever, people would have thought you were insane and locked you up. But there's a load of hands here, and we're at a conference, and everything's fine. So with that sort of context, let's take another jump backwards in time to the world of enterprise software. There's some names everyone will be familiar with. Obviously, a lot more names people will be familiar with. But IBM, SAP, VMware, Oracle, like big companies with a certain reputation and a certain amount of revenue. And I probably put that slide up, and not everyone would probably had a happy reaction. Not everyone was probably thinking like I put up slides of sort of like Netflix and Etsy and Amazon, and people were like, yeah. And I put up a slide with like IBM and SAP and others. Like, and they're probably like, did you have the same reaction? Like, what I will tell you is everyone wants to be an enterprise software vendor. So, like, more slides, more logos. Again, like, probably a different reaction in terms of your sort of, oh, do I like them? Do I want to be them? Do they have animals? But like, I'm total congrats to MuleSoft for going public just now. They make my narrative nice and easy. Like, these are companies, and there are many other companies I could have picked that want to be. I'm like, no, really, everyone wants to be an enterprise software company. And some of this is literally just to do with like how the market incentivizes companies to grow and what software companies mean. But there's certainly money in being an enterprise software company. Like, loads of people forget just how big Oracle are. If you wonder why Oracle work the way they do, it's like nearly 200 billion US market cap. It's like, that's so interesting. Like, everyone on the other slide would have been like, if they're not any of them are public companies, but there would be like the line at the bottom. So, but what does that mean for the software that they produce? So, well, Puppet Enterprise, obviously I work with Puppet. I have data from there, which is really why I'm using it. We ship Puppet Enterprise every 3 months. We ship a number of the sort of the open source components a bit faster. But Puppet Enterprise, the real product, ships every 3 months. Docker Enterprise Edition that they've just announced, again, like ships every 3 months. vSphere from VMware ships rough. Like they don't have a fixed cadence, but basically like averaging out over the past number of releases, it's roughly every 6 months. Oracle ships a new version of their database every 3 years. Again, like I don't think it's fixed, but give or take over the past 12, 15 years or so. Can this be continuous delivery? Hypothetical question. Another quick example that I think often gets brought up because it's amazing. This is not a new book, but you should totally read it. It's about the HP LaserJet firmware project, where, again, in 2008, they were doing 1 build a week. This isn't like releasing software in any way. They were able to do 1 build a week. They've got like several years later. Like this is sort of proper like transformation stuff. But even so, that regression tests 24 hours. They were able to do 10 builds a day. Is this continuous delivery? So the question really is and for people who are maybe producing even complicated sort of like web applications, why is this different? Why do the numbers seem worse, or at least larger or smaller, depending on what the numbers are? Why are they often orders of magnitude different? What's the difference? So I'll run through a number of different sort of areas where it's different, and then come back to sort of areas where it's the same. So one of them is just like consuming software via pull versus push. So I think a typical web application sort of looks a bit like this. You have it you at some point you go like, we're going to have a deployment. That might be because some code was checked into master, some code was checked in somewhere, someone pressed a button, it doesn't really matter. At some point, however your organization has decided to do it, you decide to have a deployment. You push up a running application, that's magic. Some things happen. You have some deployment scripts, you have a deployment tool, whatever, however, and your users can consume your application. They can consume it via a web browser, via HTTP, via other protocols. And suddenly you want to have a new version, and your new version replaces the old one. So you've, broadly speaking, still got the same number of users. Maybe you've got more users. You did a deployment. You now have another version. Jobs are good. And you do this every day, every week, every month, whatever sort of cadence suits you, many times a day. Deployment of on-premise software is disconnected from its consumption. So one of the things there was every time you deployed, your users got new software. That's incredibly powerful. It's incredibly useful, and it's totally not how on-premise software works. deployment's disconnected, and ultimately you still have that concept of deployment, of releasing something, but ultimately you're making that available to be downloaded. One of the downsides, and I'll come back to why this is a terrible thing later, is that new deployments don't really replace old ones. They're additive. Ultimately, people might have already downloaded that sort of package. They might want to be able to download previous versions of your software. Suddenly it starts to become a lot more annoyingly complicated. Because consumers choose when they pull your software. They get a local copy. They choose when they pull. Different people can pull at different times. Suddenly, everything is different. We've moved from like that sort of ideal, like, oh, I deploy and everyone gets the new version, give or take, straight away, to anyone could have any version of the software I've released. If you think about the sort of like the many deploys a day story, if you're deploying like that, like this, like many times a day, how many different versions are available for people to be running? And does that cause you problems later? Short version is yes, and I'll come on to some of those problems. You also have things like users can choose not to update at all, however much you convince them otherwise. You also have an interesting area here where people may choose to package your software differently to you. That is a whole other area of sort of like actually some benefits, but also some pain points when you're trying to think about things in a continuous delivery world. So that's sort of an interesting difference, I think, that has some sort of knock-on effects. There's also the fact that like the end user controls the environment in which they're running their software. And yes, the end user controls the web browser, but trust me, there's a small number of permutations there, give or take. Standards have got better. I used to do a lot of front-end engineering, and like it's a lot more straightforward from the point of view of the client today than maybe it used to be. Mobile caveats there and a bunch of other bits and pieces. But end user, like where the user chooses into what environment they install, it gets pretty terrible pretty quickly. And really, how many platforms does your web application need to run on? Yes, there's the browser side, but actually, when it comes to your deploying that application in some sort of environment, you've probably picked an operating system. Maybe you work in an organization which has been around a little bit longer, and you've got a few. Maybe you've got slightly more than you want, and you're trying to consolidate at the same time as someone saying, well, we should launch a new version of X. Maybe you've got several versions of Windows, and maybe you've got a few versions of Linux. But ultimately, you're in control of that. And you could consolidate if you chose. When you're releasing software for other people to consume, it turns out they've all made their independent decisions. And even if they've picked one, they've all picked one differently to each other. So another case in point of this, how crazy this sort of gets, the Puppet is composed of different bits of software. The Puppet Master is the sort of thing that sits in the middle. And ultimately, that supports 15 different platforms. And across sort of different versions of Linux operating systems, different versions of those, all on the same architecture actually, because that's sort of a singular bit you have in the middle. So 15, like that's got worse pretty quickly. That's sort of the tip of the iceberg. I think we currently support more than 80 platforms on top of the 15 for like some of the other bits and pieces of software. The permutations here get crazy. So you end up with different architectures. So Z systems and Power. You end up with like operating systems that won't die, like Solaris. You end up with things like RHEL 4 that was released in 2005 that people are happily still running. Like, how many versions of macOS do you choose to support? How many versions of Windows do you choose to support? And these are just examples from us. Different vendors will have different matrices, like where sort of special because of the infrastructure management bit, but also small and young-ish compared to certainly the big players. The permutations here get really insane. Think about that in terms of your CI system. So I mean, again, like numbers that I can easily access from my work. Like we run about 500 pipelines a day across our CI system for for basically parts of the Puppet Enterprise stack. That's about 35,000 individual jobs a week. Again, like the number of jobs for a pipeline is a lot. And that's for a relatively small development team. And that's all to do with the craziness of this sort of permutation explosion. Our CI system involves standing up like physical, like basically accessing locked physical devices because you can't virtualize AIX, or virtualizing various network gear like doesn't exist. Turns out AWS won't make services just for us. Your users control the environment, not you, and like that is like we also, by the way, have a web UI which we have to deal with the browsers as well. So it's not that we skip one problem for another; it's just all terrible. So more problems. I go problems all the time. Yes, like say semantic versioning one more time. I think that's probably a direct quote from one of my colleagues in our release engineering team. Versioning seems conceptually a really simple thing to consider. Like, we have semantic versioning, job done. Like, move on, yep, we've all agreed on that on the internet. Everything's kosher, right? Actually, most people don't need to deal with versioning at all as a producer. And what version of GitHub do I use? Like when I was checking in some code earlier, I have no idea. It's not exposed to me anywhere. I don't need to know. It might have changed while I was interacting with it. I didn't need to know. Most people are not actually producing software to the outside world where versioning is actually a concern. You might be producing components internally, but that's a much smaller surface area and a different type of problem. You're not, like, what's the version of the integrated whole? And how do you rev that? And what does semantic versioning mean in that world? But you do end up with versions. For example, GitHub Enterprise has a version number. It's the same software, it's the same product, but it's packaged and released in a different way. Again, because it has this discrete, specific deliverable. So here you can see you can download all of these different versions on this one page, and they do have specific versions. And somewhere behind the scenes, GitHub will tie like these two specific releases that went out on specific days of the GitHub that like we use as github.com. More craziness in versioning. Who knew that Windows 8 is really Windows 6.2? A couple of hands. I apologize for your knowledge there. And now everyone knows, and everyone can be slightly like, I don't know what numbers mean anymore. This isn't a table I've made up. This is a table from the Windows documentation, which maps the version numbers to the version numbers. Which, and at some point they've just gone like, honestly, stop it. Windows 10 is version 10. Of course, Windows Server 2016 is also version 10. Again, like because we're talking about two different things. We're talking about version numbers for the same thing for different purposes. Version numbers are marketing too. Like just incrementing, like going like, oh no, all of these Windows things were like 6.1, 6.2, 6. Like no one would have bought any of that. Not that they necessarily bought Vista anyway. There's lots of sort of examples of, again, like infrastructure examples, but like lots of examples of different naming schemes. So Puppet follows the sort of like year dot number, so we end up with sort of 2017.1.1, 2017.2. In terms of like the first bit is the year, the second bit is the number of releases in that period. Ubuntu people are pretty familiar with sort of like 1604, so like 2016-04. They do full dates, so basically 04 is the fourth month. Docker are doing the same for their new release scheme, which I'll come to in a moment. But you end up with other bits, like sort of Office 2016, excellent, that was released in 2016, I think. Office 365 was not released in the year 365. And then you end up with people who just go like, honestly, numbers give people too much credit for like what it means, and so you end up with naming like OpenStack. I presume the OpenStack project ends when it gets to a Z release. I'm not going to make a joke. Someone's making it for me. semantic versioning is not the only way of versioning, actually, when it comes to packaged software. It has a lot of downsides. You start and end up going like, well, actually, do you rev a major version whenever any component revs a major version? How quickly does that get out of hand if you have 100 components? Like, and when do you release those things? You end up releasing like version 1, then releasing version 7029, then releasing, and like, that's fine for geeks, but like no one is going to put that on the marketing material. Calva is sort of like a semi-standard around that sort of some of those date numbering schemes. Other people are doing, and like again, if you're targeting purely very technical audiences, like you can get away with doing sort of like just like build numbers. So Koros here, like they have 3 channels, and they keep a consistent build number, but you can see there's gaps because they release them when they're stable in the previous one, and then they update them. So that's sort of interesting. But again, like, would that make sense to a sort of a less technical audience? It's sort of questionable. You could totally do it. Like, someone next year should pitch a talk literally about version numbers, and it would be a shoo-in, I'm sure. This blog post actually from 2007, like, it has some background, but things have changed with continuous delivery. Updating this for how we work now would be super interesting. Versioning packaging software is a wicked problem is the short version of the conclusion to that entire talk. It's much more interesting than semantic versioning. Some of that comes on to why are version numbers important anyway. And some of that is how many versions of the software can you support at once? Because if you're going to package up software, whether you're going to sell it or not, you want to imply or provide some level of support, even if it's an open source sort of packaged software that like you're just doing yourself. The beauty of some of the continuous delivery stuff is ultimately the ideal number of things you're supporting at any given time is 1. I have one thing running. I deploy. I've changed that one thing. I've now got this new one thing running, and that's the thing I need to support. That's a massive simplifying concern. Like, how long do you support that one version for? Well, until you ship the next one. It's like, I think one of the things that's not always sort of like made explicit with some of the continuous delivery sort of patterns and talks, as they apply to sort of traditional sort of web application type bits and websites, is this: the massive minimizing of like sort of the concept of supporting multiple versions. Turns out in enterprise software land, that just doesn't work anywhere. I'll pick on RHEL because basically it's pretty amazing. So RHEL, Red Hat Enterprise Linux, this is their sort of like support lifecycle. You'll note it's quite long. Even the first production release is supported for 5.5 years. The RHEL dates, there are currently 5 major versions. They're like 4 of them are currently in support, plus all the minor versions. RHEL 4 I mentioned earlier, like its end of life is this month. If anyone here is running RHEL 4 servers, like you probably should have done something by now. Go home and plan. It's been supported for 12 years. That's a long time. Like 12 years. Like, your continuous delivery thing that you shipped to master this morning before you like got on the train to come here and everything is fine. Imagine if that was supported for the next 12 years, what would you do differently? Probably something. Possibly in a different job. The Docker support scheme, a little bit about this just happened really quick, a couple of weeks ago. And they sort of put this scheme and with a bunch of sort of bits. And ultimately, they've moved to a model where they're releasing quarterly, sort of fixed releases. Each release is supported for a year. Basically gives you the fact that like, you're always supporting 4 major versions. How minor versions fit into that is sort of like, can you force people to update? In theory, yes. In practice, maybe not, depending on how much money they're giving you. And like, so you end up with certainly more than 1. You end up with, and that's 4 releases to support at any given time. On a year, if you're shipping 4 times a year. Like, so from a certain point of view, 4 times a year, that's slow. From another point of view, is like, I've just made my support burden 4 times bigger by shipping on a quarter. How much further do you want me to go? There were some interesting comments, interesting inverted commas, on the Hacker News thread on this. Docker not supporting a version for longer than a year is a no-go. This is not enterprise-ready enterprise. In large enterprise, it will take 6 months to get a version certified to work with tooling, so we need 3 years at a minimum to put into effort. This was sort of people ranting on the internet. But bearing in mind, we've said, well, if supporting it for like a year, you end up with 4 things to support if you're releasing every quarter. Someone probably somewhere is saying, like, oh, you should release more often, and you should support it for 3 years. And it's like, the support burden for that becomes a nightmare. Also, someone did point out that like asking for a 3-year release from a company that's 4 years old is probably like, again, like that 12-year thing is like, that's like a portion, that's a suitable portion of my life. Like, to think about releasing software for, like, am I on call for that? Like, how does this work? Like, you end up with differences that are quite interesting. User expectations vary wildly across organizations, sectors, and types of software. Trying to just sort of apply one mental model to another, it doesn't work. Licenses. Again, like, you could have an entire conference about software licenses, and it would be amazing for me and about a small number of other people. Who's ever had to do a license audit? Oh, you haven't lived. One of the things, I mean, like, to a degree, this is easier for like simply putting things on the internet because most things are hidden behind the scenes, and that gives you some like fluffy ways around things. It also gives you some legal ways around things. If you're shipping software as packages, most of those licenses have like they apply in different ways. So like we have a page up with all the license information for all of the software that goes into all of the things we ship. And again, like just as one component, Puppet Server, has 170 different open source components, each with individual license terms. That's one part of the software stack. I didn't bother counting everything else, but it's probably north of 100 different, 1,000 different components into Puppet Enterprise. Puppet Enterprise is not that big. Other things will have more. Understanding like that landscape is a non-trivial problem. And I think in total, we ship things with 19 different licenses. Like open source, it's all just one thing. No, it's all sorts of different licenses with different license terms, some of which overlap in novel and interesting ways. And like, what's the difference between Artistic 1 and Artistic 2? It's been a university challenge question that literally no one would get right. Like the idea of like, does this commit break the law? Like, who has got legal policy checks in their CI system for this stuff? And if you don't have, can you just simply release from master without that sort of check, without that sort of assurance that actually, even if you've hit a good known point, someone hasn't added something new or something hasn't bumped a new version, it was relicensed in doing so, and like you just shipped something to like lots of people that's illegal. That would be bad if you're a software company. It would be bad if you're anyone, but it would be very bad if you're a software company. So it's not all terrible is the good news. That's sort of a load of problems. I could probably find more, but let's get a bit more positive. Like, how do we evolve software using the practices of continuous delivery in this context, in this sort of world? Well, some of the things we know and love are actually totally applicable here as well. So feature flags and conducting experiments. This is something that, like whether it's so you've picked it up from the sort of lean talk or from continuous delivery or elsewhere, this is something that's known to be good. How do we do that in this context? So one of those ways is ultimately allowing users to opt into some functionality. Provide them with cool stuff. Maybe that is known to break, but we're not going to support it as much, and allow them to opt in. So a couple of examples of this are the Docker experimental flag. So Docker regularly ships experimental features. They're gated off. They're feature flagged. But you can opt into them by providing flags to the daemon. So you're choosing to opt into something that maybe comes with different characteristics. Like, this might break your system. Like, we don't think the other software will break your system. Turning this on, this might break your system, and it will be your fault. But hey, the feature's cool. You should totally check it out. Like, that's a nice, like, you've sort of released two things in one. And that's the idea with that idea of feature flags. We're just pushing the responsibility to the user to enable or disable them. That's a bit different to how you might, on an implementation level, to how you might have it when you just have this one single website. But it's not fundamentally different. Like, you can't control the sample size in quite the same way. Like, you're letting users control that sample size, but you can still conduct experiments. You can still have people try out code before it's ready. We did this really successfully with what was sort of named, unironic at the time, the future parser. Like, Puppet is a domain-specific language. It has a language parser. The original parser was basically Twine and String, and we built a proper, actual, like, sort of lexical parser. But we did that that was a big project over a long period of time, but we wanted to get it out into people's hands so they could use it and test it, because then we could get feedback, but we didn't have anywhere near enough data to just ship it. So this shipped as this was the big change for one of our major releases. But actually there was a year and a half before then when we'd been shipping incremental bits and pieces behind a flag. And people could opt into that and they would get new features and they would get like better, but with the caveat that it might explode. And that was really successful. And again, like, the period of time over which that was done, that experiment was run, was longer than you would probably do something elsewhere. You can also do dark launches and test in the background. Again, like, things like this are they're often hidden. They'd be hidden on a website, but like they're hidden so there's no different there. But people don't necessarily expect them to be happening. Like Terraform does this, and like sometimes you get this sort of expected behavior, apply complete, actual behavior. This is not an error. Your Terraform operation completed successfully. Like, we didn't break anything, but we were trying out a new feature behind the scenes. It's really, like, Terraform's open source. You can splunk through the code. You can see this happening. But it's a really good, like, they get feedback about features that are coming that haven't shipped yet. It's not working yet. It's just testing whether this is probably going to work when we ship. They've dark launched something. Super interesting. So some of the patterns work. What about other patterns can we find that sort of work? So again, like, the idea of sort of releasing every commit, whether that's to master or whatever, or when you promote it into something, like, I won't go into that. Ultimately, it's the same. But how can we talked about like the horrors of support and the timescales of which things are released, partly because of how people then pull that software into themselves. They're not going to update their software every day. The concept of nightly builds sort of kicks around. Often these are not actually nightly, or even sometimes they're not even daily. But that concept of nightly builds are sort of stuck around as a banner. I often point out that like time zones, sort of like nightly builds. I work for a Portland software company out of Cambridge in the UK. If people call things nightly, I get annoyed at sort of localization things. So in here we say like our automated systems create new nightly repositories, nightly in inverted commas, like for builds that pass our acceptance testing on the most popular platforms. Well, so lots of people do that with websites as well. Like we ship packages whenever anything passes our entire acceptance testing suite. But we don't sort of push people towards those as the de facto way of installing things. They're there for crazy people to try things out, or people who want to be on the cutting edge, like see what's coming before releases happen. The Kubernetes project does this as well and makes them available. Again, any build, actually all the builds, including ones that fail the test, are available, but they have an alias for the last known good build. So if you want to stay on the edge of Kubernetes, super easy to do, just pull the packages from there, jobs are good. And lots of other software projects do this as well. And again, like you're allowing users to opt in, but users are already opting into when they pull your software. They're now just able to opt into when they pull your software and what they choose to pull. And again, we can gate those around different constraints, different support characteristics. It's this difference between being able to ship every day versus actually shipping every day. And that's sort of like sometimes lost, like that sort of continuous delivery versus deployment argument. Is it continuous deployment if we ship packages every every time they pass our acceptance tests, even though we say don't use those unless you're actually opting in to being not unsupported? I think so, yes. Product analytics, like without sort of data, you can't do experiments really. So part of continuous delivery is continuous improvement. Without that data, how do we get the feedback cycle? How do we get things better? So a hypothetical question, like, do you expect a web application adopting continuous delivery to be tracking everything that anyone does on that site? Like Google Analytics or anything other than that? Like, you probably think, yeah, of course, they've got all the data and they can make this better. Do you expect the same thing for a command line tool or something you run on your own servers or something that's open source? I think my sort of like anecdotal evidence of asking this question is people are like, no, not at all. Like, first one is yes, 100%. Second one is no, 100%, nearly. The reality is often a lot more complicated. A lot of these tools are collecting data about you. And again, HashiCorp have this sort of checkpoint service that crops up in a bunch of places that they have all their services send instrumentation to. And like, Console makes use of HashiCorp service called Checkpoint, which is used to check for updates and critical security bulletins. So you get some user benefit. That's how it knows that, like, you've got, oh, cool, it needs to be updated. Fantastic, job's a good one. It also uses that to collect data that can be used to make the tool better. The Docker for Mac and Docker for Windows and Docker for others like have this sort of, again, like usage statistics. We collect data from people as well as part of the tools. Often there's ways of opting out of these. But like without that data, we can't improve the tools as quickly. There's a bunch of problems here around not everyone being connected to the internet. Like, how do you collect data from people who want to give you it but are offline? Questions around package software and product analytics, though, are super touchy subjects. I can see a few people going like, my CLI tool is talking to the internet and sending data about its usage, but I use that for important work. Well, you probably do that with your email client, but you haven't. You're like, yeah, of course they've got the analytics. It's a really interesting disconnect. So, in conclusion, enterprise users' expectations clash with some of the expected implementations of the practices of continuous delivery, I think. But the practices themselves are totally applicable in all sorts of different spaces, like just with different implementations or different, like, slight changes. Continuous delivery, I think, is at least partially, but often in people's heads, a lot more than partially, about speed. But speed is totally a relative measure. It depends on the frame of reference. It depends on the context. And certainly for packaged software, for enterprise software, it's a different context. And always put that context and your users ahead of any sort of absolute measures. Once a day or many times a day deployments aren't always suitable. It depends on who you are and where you are. Thank you. I don't think I've got time for questions, but I'll be around afterwards.